In this video, we're going to solve the following problem. Write an equivalent expression using radical notation. So let's first figure out a little bit about what's meant by fractional exponents. So let's first look at the expression the square root of a times the square root of a. The square root of a times the square root of a is going to be equal to a. And the reason it's equal to a is because each one of these represents the value that needs to be multiplied by itself in order to get a. And so here I am taking the value that needs to be multiplied by itself, and I'm multiplying it by itself to get a. And I get that on the other side. But also, if we think about the rules of exponents, if I had a to the 1/2 power times a to the 1/2 power, when we're multiplying the same basis, we can simplify by adding the exponents. So that would be a to the 1/2 plus 1/2, and that would be a to the 1 power, or simply a. So here I have a number that when multiplied by itself gives me a, in the same way that the square root of a when multiplied by itself gives me a. So that means that the square root of a is the same thing as a to the 1/2 power. And similarly, we can do this if we think about cube roots as well. The cube root of a times the cube root of a times the cube root of a is going to be equal to a. And why is that true? Because this quantity, cube root of a, represents a number that when multiplied by itself 3 times gives a. And here I am, I'm multiplying it by itself 1, 2, 3 times, so that should give me the value a. If we look at a to the 1/3 power times a to the 1/3 power times a to the 1/3 power, again, these all have the same base, so I can simplify this expression by adding together the exponents. But 1/3 plus 1/3 plus 1/3 is equal to 1. So here I have a value that when I multiply it by itself 3 times gives me a. So that means that the cube root of a is going to be equal to a to the 1/3 power. And you can see that we could continue this for fourths and fifths and sixths and so on. And so in general, we say that if we take the nth root of a number or a variable, that's the same thing as raising that variable to the 1/n power. So now let's go back to our original question that asked us to write a to the 3/5 using radical notation. So the first thing we're going to do is we're going to notice that we could rewrite this as 3 times 1/5, and 3 times 1/5 would be, we'll do that off on this, 3 over 1 times 1 over 5, which would give us 3/5. So this is an okay way to rewrite that expression. And now that we've rewritten it that way, we can think of this as a cubed raised to the 1/5 power. And that's just using the rule of exponents that tells us if we have x to the n power and we raise that to the m power, that's the same as x to the m times n. So instead of using this rule in the traditional direction, which goes from here to here, I've used it in the opposite direction. I've started with something on this side and written it in that way. Now that we've rewritten the problem this way, we can think about this fractional exponent as being a root. That's the 1/5 power, so that would correspond to the 5th root, and we would rewrite this as the 5th root of a cubed. Now in practice, when you're doing these problems, you're usually probably going to go straight from here to here without those intermediate steps. And you'll think of the denominator here as becoming the index of the radical and the numerator as staying the power of the base. I hope you found this helpful.